Hi guys, Mr. Kane here.
Hi guys, Mrs. G.
Good to see you again. If you're not part of the precipitate, you're part of the solution.
Right into it.
Yeah,
Unit
okay.
14.
All right, Unit 14,
Solutions.
here we go. Solutions. All right, goals for Unit 14.
Describe the properties of solutions. Identify the different parts of a solution.
All right, so
You've got solution.
right, the solution, right?
The
So the
solution is made up
parts.
of parts. Oh my God, we're thinking alike. Solvent, solute, know those definitions. Differentiate among saturated, unsaturated, and supersaturated solutions. Determine the types of solutions and number of grams of solute graphically using solubility curves.
Wow, that's a mouthful.
Yeah, that was blah, blah, blah.
Yeah. So we're going to
There's
look
a
at
lot.
graphs.
Yes,
Okay.
basically speaking. You're going to read a graph.
And
Measure the concentration of solutions in terms of molarity and mass percent, which you're going to need a calculator for.
okay.
Oh, and calculate dilution. There you go, another calculator.
There we go. So two
Almost forgot
times
that
the
guy.
calculator. So it's a definition of a solution.
So,
Since
yeah, what
that's what we're
exactly is a
studying.
solution?
A solution is homogeneous. Reminder, homo meaning the same, genius meaning kind of looking like that, so it's looking the same throughout.
Yep.
So it's a mixture that where a sample from one part of the mixture is going to be identical to samples from the other parts.
Right. Like the air you breathe
Right.
is a homogeneous mixture of 9 different gases. You don't get more oxygen because you're in the gym than you do in this classroom.
No.
It's exactly the same makeup.
Yeah, if you want more oxygen, you have to go to the hospital and get hooked up to
Right.
a tank. That's pure oxygen, right?
Right.
Yeah. Okay. Kool-Aid is a nice homogeneous solution. The way they tell you to make it on the package.
All right.
You know, if you don't make it the way they tell you to make it on the package, and you do like I used to do and put way too much sugar in, then it's not homogeneous.
Not so much homogeneous
Yeah.
anymore.
Yeah, because then you got stuff floating on the bottom. Brass.
Which I find very interesting because note that a solution is not necessarily limited to liquid phases.
Yeah. Nowhere does it say that it has to be liquid,
Nope.
and the air around us is a gas.
Yeah, we
so
just
we've went
discussed all 3 phases.
solid, liquids, and gases.
A
Very
solution
interesting.
can be either a solid, a liquid, or a gas.
And there's an equation down here, Miss G.
Yes, because a solute plus a solvent will sum up to be the solution.
I don't understand. Solute, solvent.
Solute and solvent make up the solution. The solute will be either the solid that is dissolved or the smallest amount of the solution. The smaller amount of the solution.
The smaller part.
Or a smaller part. A solvent will be the dissolver of a solid or the largest part of a solution. And the reason there's kind of like 2 categories is, what if you are dealing with a liquid in a liquid? Then how do you distinguish solute versus solvent?
That's got to be the smaller amount of
Smallest
solute.
amount versus the largest amount, like 70% isopropyl alcohol, which you buy at the grocery store.
Oh, you use that on your cuts to
Right,
clean them
use
off.
it on your cuts. We used to use it on our newly pierced ears. 70% isopropyl alcohol literally says 70% isopropyl. That's the solvent.
And then the other part's water?
30% is water.
Oh, okay.
So
All right.
water is the solute.
Okay, so solubility and polarity. It says
Okay.
here likes dissolve like.
Likes, dissolve, likes.
So that means that water's polar, so it will dissolve polar things.
Correct.
Right.
Polar molecules. Yep.
Okay.
Real life applications. Oh, cool. Vitamin C. Vitamin C is a water-soluble vitamin.
Yeah, and sometimes people say when you're getting a cold, take as much vitamin C as you want, right?
Right.
So that you can get rid of the cold. That's okay because you're not going to overdose on vitamin C.
Right, because your body doesn't absorb it. You pee it out.
Right, exactly. As long as you got enough urine, you can
Yep.
get rid of it. So
Yes.
you're in luck.
Because it is water-soluble, it goes into your bloodstream, not your muscles or fat.
Now, of course, if you took the whole jar at once, that bad things happen, but within reasonable amounts you can take.
Right.
Vitamin A, though, on the other hand,
It's fat-soluble.
It's fat-soluble.
Will not dissolve in water. Will only dissolve in fat because it is not a polar molecule.
and no matter how athletic you are, you got some fat. So if you take too much vitamin A, it'll build up in your fat,
Yeah.
and you'll overdose on it. So that can be a bad thing.
Ooh, definitions. Miscible versus immiscible.
So miscible liquids are those that are completely soluble within each other, and immiscible liquids do not mix.
Okay.
We've got a grand example of immiscible liquids over here.
Oil and vinegar.
Oil and vinegar, or oil and water. Salad dressing, right?
Yeah, salad dressing.
Okay.
Solubility of ions in water. Ooh, I remember solubility. Wasn't that solubility rules?
Yeah, we did solubility rules before.
Yep.
It turns out that certain things are soluble in water. We can look them up on the solubility chart.
Right. You guys didn't have to memorize anything for solubility rules. The chart was always given to you.
But the basic reminder here is that when something does get dissolved, a salt does get dissolved in water, it is actually disassociated. The ions separate.
So I see a nice link here, Mr. Kane. The sodium chloride is the solute.
Okay.
The beaker of water is the solvent.
Uh-huh.
And the final picture there on the right is the solution of aqueous sodium chloride.
Something plus something equals something.
Yep.
That's great.
Ooh, this is what happens at the super submicroscopic level, huh?
Yeah, exactly. You got your polar water molecule here. Now notice the partial charges. The hydrogens are partially positive, oxygens partially negative.
Yep.
And they are going to latch on to this negative ion here, the anion. On the other hand, the cations are going to get carried away by the oxygen end of the water, the negative end of it.
So when the sodium chloride dissociates, the water molecules surround it in a very particular orientation.
And you can see here the ions. Here's the anion. It's surrounded completely by the positive portion of the polar water molecule. And down here the cation is completely surrounded by the negative portion of the water molecule.
Solubility of polar substances in water.
Okay, so something like this. This looks like C2...
Ethanol.
Yeah, ethanol.
Yep.
And you can see that just a partial part of it is actually polar. So that means that only this part of it is going to interact with water very well.
So it'll dissolve in water. It's not going to dissociate because,
No,
of course, it's not a soluble
because this
salt.
covalent bond won't be broken
Right, but
by the water molecules.
the end there, that oxygen-hydrogen end, makes it just polar enough to dissolve in water, and likes dissolve likes.
They got some dots here, and they call that something, don't they?
They call that an intermolecular force. It's an electrostatic attraction. Ooh, octane.
So we got octane here. That's what they put in gasoline, isn't it?
Yep.
The octane molecule is... I don't see any polar bond here.
Yep, the carbon-hydrogen bonds are not polar. We found that out with the difference in electronegativity, so that entire molecule is non-polar.
So it's completely nonpolar, so this won't dissolve in water. What will it do?
It'll just separate completely.
Oh, kind of like salad dressing.
Yeah, it'll sit on top of the water.
Oh, kind of like that?
Yes, kind of like, although it's pretty,
That is pretty, yeah.
but it doesn't. Well, water will not dissolve it.
So that's what we see on at gas stations and
Yep.
when it rains.
Any
right?
of the hydrocarbons, water will not dissolve any of them.
Right.
Factors that affect the rate of dissolving solids. Oh,
Before.
well, temperature makes sense because, of course, the hotter something is, the more you can dissolve.
Right. At a higher temperature rate, the rate of dissolving goes up.
Right.
Right. Particle size. Do you want to dissolve something that's a large chunk or tiny little pieces?
Right, because look at the pictures. It's easier to attack the right-hand picture than it is the left-hand side.
Right.
So
the water
it makes
molecules are going to
sense
have a
that,
lot easier time getting around.
Kind of like military.
Okay. So as the particle size decreases, the rate increases.
Okay.
Okay. Mixing. You can mix things, and the more you mix it,
Yeah.
the faster things dissolve, right?
Right. Sugar, tea.
Yeah. And sometimes the nature of the solvent or the solute, we mentioned that before, the polar and nonpolar. Polar things tend to dissolve better in polar substances because it doesn't seem to be happening anymore. Okay.
Definitions?
So definitions for solubility here.
Okay.
It turns out there are 3 different types of solutions.
All right.
There's an unsaturated solution where you have just a little bit of solute in it,
Okay.
relatively speaking, and you could dissolve more. So
All
if you
right.
put a pinch more in, it would dissolve.
I think I equate this to lemonade.
Okay.
Making lemonade, the powder in the lemonade. So my unsaturated solution is not enough powder.
Okay, so you could add some more powder and it'll still dissolve.
You did not make it right. There is too little powder in your lemonade.
Okay, and a saturated solution is one where you are not going to be able to dissolve any more into it.
Right, it's the perfect glass of lemonade. Everything has dissolved, it looks beautiful, it tastes great, it's perfect.
And if I added a spoonful more of the lemonade powder,
yuck, be too much.
It wouldn't dissolve, right? It'd fall to the bottom.
That is correct.
And then finally, a supersaturated solution is one where you somehow get it to dissolve more than it's supposed to.
Supersaturated solution is like way too much powder in your lemonade.
Yeah. Matter of fact, I know a little bit about supersaturated solutions. My bees make supersaturated solutions.
Yeah.
Honey is a supersaturated solution of sugar and water.
Oh.
There's about there's about 87% sugar and about 13% water in honey.
Oh.
And one of the ways you can tell a supersaturated solution is that it sometimes will form crystals in it. Sometimes if you leave honey sit long enough, it actually forms crystals.
So is that kind of like saying the excess comes out?
Yeah, the excess
of
kind of
the water.
Yeah, it kind of crystallizes
right.
out. And you'll notice that there's an arrow here, guys. There's an increasing concentration as we go from left to right.
Which would make sense. The left side is too little.
Right.
The middle is perfect.
Mm-hmm.
The right side is too much.
Man, it reminds me of the Three Little Bears.
Yeah, there you go.
Okay, so here's an example of a supersaturated solution. This one is made up of sodium acetates. It was made up by heating up some water and putting the sodium acetate in it and dissolving as much sodium acetate as we could at that higher temperature.
So you can dissolve more stuff at a higher temperature.
That's a good generalization. Yeah.
What happens when the temperature comes back down? Because you can't, unless you keep it on the hot plate.
Right. If it comes back down at a reasonable rate, you just leave it sit there and cool.
Okay.
It's going to stay in solution just like you see here.
Mm-hmm. Okay.
Same as honey.
All right.
However, these supersaturated solutions tend to be a bit fragile.
Okay.
So if you disturb them somehow, you can actually make them crystallize.
Yep, because they're unstable.
Some of them are easier to disturb than others. This one's really easy to disturb. You can actually just tap the side of the beaker with a pen, and that'll be enough. Or sometimes people like to toss one more crystal in.
Over the top,
yeah? You just, it's like the straw that broke the camel's back. So if you watch very carefully, you're going to see it drop. We're going to drop a crystal in right about now. There it is.
Oh, neato.
And it looks kind of like it's snowing or something, but that's actually crystallization crystals forming.